Hi, everyone. You're listening to The Dicto, a podcast exploring intelligence from a variety of perspectives. Today, I have the pleasure of having Sir Simon Baron Cohen as my guest. We will explore pattern recognition and its central role in both natural and artificial intelligence. Sir Simon Baron Cohen is a professor of developmental psychopathology, director of Autism Research Center, and a fellow at Trinity College, Cambridge. Simon's research focuses on a subgroup of people who derive their greatest pleasure in life from deconstructing the chaos of nature into its underlying principles. Yet, despite providing the humankind with its most important inventions and discoveries, this group of people is routinely stigmatized and marginalized. The group I'm referring to are the autistic people. This year, for Simon's outstanding contributions towards the people with autism, he has been knighted. Congratulations, sir, and thank you for making the world a kinder place.
So thank you for inviting me onto the podcast, and it's a pleasure to meet you.
Likewise. To begin the conversation, could you please introduce the systemizing mechanism that you describe in your book, The Pattern Seekers?
Sure. So the idea is that in the human brain, but uniquely in the brain of Homo sapiens, there's a mechanism that can recognize a special kind of pattern in the world. I call them if and then patterns. And this kind of logic, it's really a causal logic, comes from the work of George Boole, who many of your listeners will have heard of, a logician from the 19th century. And, the idea is that at a certain point in our evolution, there was a change in the modern Homo sapiens brain, that we developed the capacity to see these patterns in the world, and that this capacity allows invention of any kind. So I could elaborate, but that's the basic idea.
I think it's curious how you chose particularly the if and then pattern to explain the wide variety of inventions and discoveries that we see in the humankind but cannot observe in non-human animals. And that made me wonder, why exactly do you choose the if and then pattern? Because if we, for example, think about how children can learn language with a very small amount of input, they can deduct a variety of relationships that are not explicitly mentioned. Even though we could reconstruct this learning process to explicit if and then patterns, a lot of times we don't really we don't really need to observe the explicit if and then patterns or even think about them in order to be able to reason about phenomena.
Yeah, I'm not sure whether your question is about how explicit or implicit this way of processing if and then patterns is, but it may well be that much of the time we do this implicitly, and that even when young kids are carrying out this kind of reasoning, they're doing it implicitly. So when you see a young child experimenting with their toys, they may not be consciously working through the algorithm, like with any awareness, that if I take this input and I perform this operation, then I'll get this output. They may not be consciously thinking about it, but they're just doing it. You can observe it in their play. So if you see a child maybe trying to perfect a particular move on a skateboard, as they change their balance on the skateboard, and they go through the routine over and over again, just slightly fine-tuning or playing with the patterns until they can perform the trick. That would be what I call systemizing. But equally, if they're just enjoying playing in the playground on a seesaw, so playing with the weight, where there's a central pivot, and they're playing with what happens if I push harder or push less hard or move closer to the other person. they're kind of changing the variables in this if and then sequence.
Fundamentally, it might be that the if and then patterns are not explicit, as within the skateboard example, that it's what's called muscle memory, where we subconsciously are noticing how of standing on a skateboard in different ways might affect or balance, and performing a trick in different subtle ways might affect the end result and stability.
Well, I mean, just like with language, since that's your area of interest, often when we're picking up language, we're not consciously thinking, what's the rule? How do I derive the syntactic rule? We're just kind of noticing the input. We're maybe parsing the input. So we're identifying the units. We're at some level processing what happens if you change the position of one word or another word, what happens to the whole sentence. But none of this need necessarily be conscious. Just by immersion in the language, we spot these patterns. And as young kids just seem to take off in language without consciously thinking about the rules, but they must be picking up on the rules. And the same thing is probably true in systemizing. We're not consciously thinking like a scientist. We write out our hypothesis. If I take this input and I change the conditions, then I get a different output. Human beings are often just doing rather than thinking about doing, but it's still nevertheless evidence that they're engaged in this kind of reasoning.
And you mentioned that a critical difference between human reasoning and human inventiveness, and that observed in animals, is that we might see an animal kind of having a single example of an invention. For example, putting a peanut on the road and using a car to, kind of inadvertently using a car to open that peanut. But we don't see the ability for systematic, and I would even say infinite discoveries.
Yeah, absolutely. So let's take the example of the peanut, because it's a real example that what's been observed in other species, such as birds, is they might drop the nut on the road, but particularly on the pedestrian crossing. So they've learnt that trick, that if they drop the nut on the pedestrian crossing, then when the car has gone over it and cracked open the nut, there's an opportunity to go down and get the open nut, So that's, it looks like an invention, but we don't see the bird systematically trying to open the nut in other ways, whereas unlike, in the case of humans, once we have that moment of insight that I can open the nut using a heavy weight, we don't just use the car, we might use a hammer, or we might use any kind of other device. So we're changing, in this case, the and. So the if stays the same. If there's a nut in a hard shell and I hit it with a heavy weight, then I can open the nut. But the way in which we perform the operation, which is the and part, we can, because we have the capacity to play with these patterns, which I think is the basis of invention. It means that we can come up with, in a generative way, we can come up with multiple inventions, not just a one-off, what seems like an invention, a one-off instance.
And similarly to being able to generate these infinite hypotheses, which might result in infinite inventions, we can also generate infinite number of sentences in a very similar way, where all that humans are doing are playing with various patterns, and we can even have simple rules that would generate sentences to unbounded length. What do you think is the relationship between if and then systemizing and the human ability to generate language?
Yeah, I think it's a great question because, and in my book, the Pattern Seekers, I kind of explore the relationship between systemizing, which is what we've been talking about, and language. And certainly there are some aspects of language which seem to use a very similar logic. And it may be that once we had the capacity to systemize, this was used in all kinds of domains, language being one of them. So systemizing is, if you like, domain general. You can use it in any domain. You could use it in music, in mathematics, in language, as we heard earlier, in mechanical activities. So it's not restricted to language, where we think of language as either auditory or written. You know, those are very specific domains. But systemizing is domain general. And it may be that some of the some of the same mechanisms that we use in systemizing are also used in language. We might think of evolution as having co-opted what already existed in one, to be used in a domain general way, also in a domain specific way.
This is an interesting perspective on the mystery that is introduced in The Language Instinct by Steven Pinker, where he argues that humans have an instinct, language for humans is as instinctive as, for example, making the webs for spiders. And it leaves with the mystery of how did the language instinct come to humans, because it involves two distinct complex mechanisms of syntax and semantics, and they are functional only when they come together. So the evolutionary gradual process is difficult to apply to this mechanism. What would be your take on this?
So I think language is more your area than mine, but I'm happy to talk about it. So I think language involves, multiple levels. We've talked so far about syntax and semantics. Maybe I would put more of an emphasis on reference in language, which is sort of subsumed under semantics, I guess. But when we're trying to derive meaning.
Well, a lot of people would say it's actually a part of it is semantics, but there's also a part that's pragmatics, ability to take into account the context of language in order to identify the most accurate reference.
Yeah, absolutely. So if we just focus on the one hand, reference, and we can talk about the simplest forms of reference and whether any other animals are capable of this. And on the other hand, pragmatics, which you've mentioned. So reference to me is all about using a word or a symbol to refer to something beyond itself. So if we take a gesture, for example, if we use the pointing gesture, which we know young human kids produce by the age of 9 to 14 months, when they're pointing at something, it's as if they're saying, I want you to look over there across space. And when they follow where somebody else is pointing, if the parent is pointing up at the sky, the young child, the typically developing young child, understands that the intention is to refer. So that's the reference part. And it's not clear that other species can do this, and to me, this is a very basic part of language, that when I use the word cup, I intend to refer to this object. So the word points to something beyond itself. And for me, that capacity for reference is part of a very different circuit in the brain. I also discuss this in the book, but it's the empathy circuit, which is a set of regions in the human brain, which can think about other people's thoughts and other people's intentions. So when we're communicating, we're not just exchanging words, but we're keeping track of what is the other person thinking, what is the other person intending, what does the other person know, and how do I need to maybe modify my message to make sure I'm being understood. That's all about empathy. That's not about logic and pattern recognition. It's a very different sort of skill. And I would say that pragmatics in language is also not just about context, but it's about, again, empathy, being able to read between the lines. So, for example, if I look at my watch and say, "Goodness, is that the time?" You can pick up that my intended meaning, my implicit meaning, is that I need to go. I need to end the conversation. This kind of pragmatic implication is more about what some psychologists or philosophers call theory of mind, being able to read another person's mind or infer what they might be thinking or intending. And that, to me, that belongs to it's enabled by a very different circuit in the brain, the empathy circuit.
And when we so this leaves us in a even bigger mess than when we started with, because now we know that we have to have the systemizing circuit and the empathy circuit combined in order to be able to produce and understand language.
Yeah. So for me, and this is my kind of proposal in the book, is that what we can see in the archaeological record is that between about 70,000 and 100,000 years ago, from the artifacts that our ancestors left behind, we can infer both the existence of the systemizing mechanism and the empathy circuit at around the same time. So if we take some examples from archaeology, so let's take the first human jewelry, which was found around 75,000 years ago.
I remember you describing it as an engraving on a seashell, right?
So the first jewelry was actually shells, as you say, not necessarily engraved, but with little holes made in
each. That's right.
Yeah, so little holes made in each shell. And, with hindsight, as archaeologists try to put together the remnants of history, what we imagine is that somebody had put a thread through all of these shells because they all have a little hole in them to make a necklace. So if that interpretation of the fragmented archaeological evidence is correct, we could imagine that 75,000 years ago, one of our ancestors made the first piece of jewelry, or at least the earliest example of jewelry.
And also displayed a connection between the systemizing mechanism and the empathy circuit.
Precisely. So, to come up with the idea of making the necklace needed the systemizing mechanism. If I take the shell and I make a hole in it, then I can thread a necklace, thread the beads into a necklace. So it's if and then. But the motivation for doing it may have also required empathy, that if I wear a piece of jewelry, then maybe the person seeing me will be impressed or be attracted. Or if I give this piece of jewelry to another person as a gift, maybe they'll be pleased. So that, in the same artifact, the necklace, we can see both systemizing and empathy coming together. And just to bring this back to language, I think that's probably exactly what happened with language. That it's the co-occurrence of systemizing and empathy that allows language. Systemizing enables a lot of syntactic computation. Empathy allows the kind of more relevant aspects of language that I'm intending to communicate, and I'm trying to imagine the thoughts of the listener, of the receiver of my communication. So just as we see kind of these two mechanisms converging to enable, the invention of jewelry, the invention of many other things, I think we might see the convergence of these two in language as well.
Okay, it's a fascinating perspective. And that also gives early evidence to spoken language, which is always a tricky subject because, unlike written language that follows a couple of tens of thousands of years after the first evidence of spoken language, we can't observe spoken language due to obvious reasons.
Yeah, absolutely. So, I can see a big challenge for your field. Like, when did language, where is the evidence for when language was present in human evolution? And I know that some approaches look at the remains of skulls that have been found from skeletons to see whether you can see a kind of trace of language areas in the brain. But this is, very speculative.
I would like to return back to the idea of combining the systemizing mechanism and the empathy circuit. So 75,000 years ago, that would have been evident in jewelry. But if we go now to one of the most obvious examples of systemizing mechanism, namely software development and kind of creation of engineering products for the society, naturally, kind of normally that's associated with strong systemizing mechanism in the creators. However, an argument that some programmers make, and as a matter of fact, quite a lot. I think Paul Graham is a strong advocate for this idea that to be a good programmer, and this applies to a variety of other disciplines, one needs to have a strong understanding, have strong empathy and strong understanding of how the end users will use the product so that we can actually create things that are useful.
If only that was always true. If only programmers always thought about how is the user going to experience, the code that I'm writing. Is the program going to be useful? Is it going to be enjoyable? Is it going to be easy to follow? And in many instances, we do see fantastic examples of that kind of engineering. So probably the reason why iPhones are so popular is because they're not just brilliant examples of programming, but they're also pleasing to the user in multiple different ways, or they're satisfying the needs of the user in multiple different ways. So we hope that that's like one example where the programmer is also using empathy, and the two come together. I have to say, when you started off your question, coming up to the present day, I thought you might talk about a different invention, which was the vaccine. Since we're talking in the time of COVID, because I sort of see the invention of the vaccine as a beautiful recent example of systemizing,
Definitely.
and or even our understanding of public health and how we can control the pandemic is a beautiful example of systemizing. If we don't have lockdown and we carry on behaving in the same way we have been, then tens of thousands of people will die. But if we change our living conditions and add lockdown, then we can reduce the number of deaths. It's the kind of if and then logic that we're using in public health today, or in the invention of a vaccine. If we take the virus and remove its RNA and inject it into a person, then that might confer immunity. It's the same kind of if and then algorithm.
I would say that when we're developing vaccines, the empathy circuit does not have to be as applicable because the usability of a vaccine is.
Yeah. I mean, and this is where I was thinking, the reason why we're in lockdown, or why scientists have been developing vaccines, is precisely because of empathy. That actually, as humans, we don't just want to invent for the sake of it, but we want to invent, in this case, to protect one another. We're trying to reduce the likelihood of death amongst the most vulnerable people in our society, usually older people or people with pre-existing conditions. So here we are, we've got scientists, developing vaccines to help other people. And again, I see this as a beautiful convergence of systemizing and empathy.
I would make an argument that one does not have to have the empathy circuit in order to, for example, put in place the lockdown measures, because, as you mentioned in your book, even people who lack the empathy circuit and have a strong systemizing mechanism still have a strong understanding of morals and human value. And we don't need kind of the fine-grained human interaction values that the empathy circuit brings in order to make such systemizing decisions in regards to what's the most effective approach of limiting virus spread.
Yeah. I mean, you could be right. You could imagine a systemizer in the time of COVID might reach the conclusion, all I have to do is stay home to protect myself. I won't care about other people. That's the empathy piece. I'll just stay home. So that, you could imagine that lockdown could have resulted just from a purely self-centered approach. But the fact that, we see this imposed by governments for the benefit of the public, of society, you could say it's just the result of the logic of how are we going to achieve the greatest good for the greatest number, some kind of purely logical reasoning. But I think you could also interpret it as signs of empathy, that what we do as a species is we do care about each other.
Definitely. And we do need that balance between systemizing and empathy circuit. However, kind of neurodiversity in workplace. So whenever we are dealing with real tasks and we have people with various uh, various ways of thinking, various types of minds, some might be more systemizing, others more empathetic. How do you what do you think is the key to combining people who think differently and making sure that the end product, if it's software, we make sure that the user is actually taken into account, or if it.
No, I think this is a great question, and I sort of addressed this a little bit in my book because we talked at the beginning of the podcast about autistic people. Autistic people, from our research, seem to have a strong interest in systems and patterns, but many of them are unemployed. So if you accept my argument that invention requires systemizing, requires this ability to think about patterns, so the kind of argument in the book is that autistic people, because they, for genetic reasons, have a strong interest and a strong aptitude in systemizing, in all likelihood, we're contributing to human progress right across the last 70,000 to 100,000 years. And yet, if we look at their situation today, many of them are unemployed outside of society. So I think we do need to think about employment. I'm glad you've mentioned it, of how can we change the workplace so that it's more inclusive for people who may have a different profile, a different way of thinking. And this is this concept of neurodiversity. But I think maybe more relevant to your question is, how can we combine these different skill sets in the workplace? So it's not always the case that within a single individual, you'll have somebody who's fantastic at systemizing and fantastic at empathy. But across a team, you could easily have these different skill sets. And I think that's the kind of the force of the argument for diversity in the workplace. If everyone's the same in the team, we're just going to get kind of clones of each other, and we're not going to get that kind of special mix that we've been talking about, the convergence of empathy and systemizing. But if you have different types of individuals in the team, if the programmer is going too far in one direction, which is not user-friendly, the empathizer can kind of check it and say, hang on a second, let's see whether we need to change the design, because otherwise the customer is not going to feel this is very useful.
I remember you mentioning more towards the end of your book how some companies choose to recruit exclusively autistic people due to their strong systematizing nature.
Yeah.
However, this kind of goes again in the other direction, where we ignore some core aspects of that are important in creating products for the users. What do you, if you were to create a team for
Mm.
creating the new iPhone, let's say, what do you think would be important considerations in making sure that your workplace is available to people who might have various minds, and also it can function towards creating a final goal?
Yeah. So the nature of industry has always been, can we take a product and make it more efficient? Can we make it more powerful, quicker, maybe smaller but better? And that needs the kind of systemizing mind. You take the challenge. This systemizing mechanism in the brain responds to problems that it's trying to solve. And all of these inventions that we talk about are the kind of the solutions that the brain comes up with to solve a problem. So in any company, we can imagine that we could employ systemizers to say, can you make this computer go faster and have more memory and whatever the output is that we're looking for? And the systemizer will find a solution. Can you make this rocket get to Mars? To take a current example, just yesterday, and that's human beings still systemizing in the 21st century, still using that if and then logic. That's how the rocket got to Mars. It's just the same 3 steps, but in a long sequence to complete the puzzle. But I think at the same time, you do need people who are more people-oriented in the team. You need, a real mix in the team. And by doing that, you're kind of recognizing the value of each of these different types of minds or brains.
Even if you're trying to optimize memory of a computer, there are still trade-offs that take place. So, for example, if we're talking about a computer, being able to empathize with users and realize whether they would need a faster computer, or would they be willing to pay more for a faster computer, or maybe it's fine to not optimize as much and have some other trade-offs.
Yeah,
We still need to have this empathy
yeah,
mechanism even when dealing with highly technical tasks.
sure. Yeah, I agree. But equally, if we look back at the history of invention, there are plenty of examples where the inventor thinks they've had a great idea and they go off down a particular track to build an invention that actually nobody wants. So it doesn't always follow that the inventor is keeping in mind the end user. And that's why I think we need the mix of individuals in the team.
Returning back to the statistical learning that's
Sure.
present in animals,
Yeah.
even the very nature of using statistical learning immediately strikes out as the deep learning approaches, or just machine learning approaches that
Mm.
currently are used synonymously with artificial intelligence in general, where we have advanced mechanisms for identifying subtle correlations within inputs that
Mm.
produce that are capable of acting as inference or produce final outputs. What do you think is do you think are the main limitations of being able to just observe correlations in inputs of everyday world?
Well, I think as you just mentioned, statistical learning is widespread in the animal kingdom. I think it's been demonstrated in many different species. Um, and in my book, what I argue is that statistical learning is, it accounts for a lot of our learning, just as, we are animals, just like many other species. but I don't think it can account for invention, because otherwise we would see particularly generative invention in other species. So the fact that other animals can do it, monkeys can do it, pigeons can do it, rats can do it, but we don't see them coming up with invention in a generative way, suggests that it may be necessary but not sufficient for invention.
Yes, looking into how we can observe maybe something that would look like invention from AI, it still is a matter of how the human supervisor tunes the environment. So, in a similar way as when we throw a pebble into the water, maybe and it becomes smoother due to just due to the interaction between the water and the stone, it happens that the water is more hydrodynamic the stone is more hydrodynamic at the end, but it does not impose any level of intelligence within this mechanism. And the same process follows in evolution, where there's uh, arguably no intelligent design, and
Mhm.
we still see uh, ability to go from simpler organisms to more complex. And if we apply the same patterns in a statistical way, even though we're missing the systemizing mechanism that is fundamental for humans to invent, we can observe inventions and better and better outputs from more computational models or from environments in general.
Um, so I'm trying to check I understand your point, because are you saying that that you can expect change across evolution, which could explain, for example, the evolution of species, uh, but by itself that wouldn't explain the evolution of invention?
Well, what I would say is that if we look at evolution as an example of invention, because as the species progress, as species evolve, they become more and more adapted to the environment. And one
Hmm.
could say that it is a type of invention.
Yeah, okay, I see where you're going with this, but I'm not sure if I completely agree. So um, if we take the evolution of, let's say, vision, the evolution of the eye, because this is an example that's been discussed a lot in biology, you know, that even a kind of simple photoreceptor, uh, might be better than no photoreceptor. So if you had the most primitive retina that could simply detect light and dark, and that's it, in a very blurred way, that might confer an advantage on the organism. That maybe that gives you an early warning system that there's a predator nearby. So it gives you a survival advantage. And then, as we know, evolution is mostly the result of genetic mutations, some of which may, by chance, confer advantages on the individual. So if the gene responsible for that very primitive photoreceptor mutates, just like the virus is mutating at the moment, a small change in the DNA mutates such that the retina can now do more than just light and dark, but it can detect, let's say, shape or edges or just some other little uh, sort of detail of vision that the old retina didn't have. You know, though the individual organism that carries that mutation might be more likely to survive and pass on its genes. So I wouldn't say that this is an example of evolution inventing, because this is pretty much a random process which is then tested, like in the market, it's tested in terms of survival. Does the individual animal survive to the age of reproduction to pass on its genes? Whereas when we think about invention, I think that the process is probably very different. But I'm happy to explore if you think it's more similar to the evolution case. But I think in invention, we do see the use of, let's call it intelligent design, because there's a strategy involved. You take the input, you perform a change, you observe the output. If the output is better or than what you had previously, then you might repeat it, or you might then play with more variables to see if you can keep, through iteration, keep refining and improving. I see a sort of difference in, in that process compared to blind the blind approach that evolution takes. In evolution, there is no master plan.
So would you say that if we take the invention template
Yeah,
and randomly assign one of the variables and then observe the quality of each of our final obtained then results, then at that point we're not doing invention anymore because we didn't have any intention when we were constructing the if and then patterns.
yeah, possibly. But I find your example really interesting and also quite challenging. You know, does invention, whoever is performing it, whether it's a human or an artificial system, when invention occurs, does there have to be a sort of a motivation, a purpose to always be looking for a better outcome? Is that kind of intrinsic to what we think of in terms of invention? Is it always, a system that's trying to solve a problem and see if the solution is a better solution than the previous one? Which I think, going back to your evolution example, I'm not sure we can sort of ascribe that kind of intention in
I would
evolution.
definitely agree
Yeah,
with you that evolution is not an example of a systematic invention as you describe it using the if and then patterns, but rather I was trying to allude to the fact that it produces an end result that
yeah,
is very similar to the result of systematic invention.
I see what you mean.
And
Yeah,
consequently, we observe that we can, for example, have machine learning algorithms that based on random, but in semi-random, while at the same time guided optimizations produce artwork or improve upon existing mechanical design. But here we have a mix of that randomness and penalty functions that we see
mm,
in evolution and sort of guided exploration process that we see in if and then patterns
yeah,
performed by humans.
yeah. No, I like the idea, and I'll think about this some more after our conversation. But certainly, I think the idea, that essentially in natural selection, effectively, genetic mutation is introducing a change, and sometimes those changes might lead to a better result. And I think probably that's the same thing that's going on in this if and then logic. The and variable is usually a causal operation. It's changing the input to a new output. So if we take an example from mathematics, you take the number 3 as your input, and then the and might be to cube the number. So you're creating a change, and then the output is 27, 3 cubed. So, but you could sort of take a different number and still perform the same change and get a different output. So, I mean, I can see it. There's a nice analogy between what goes on in systemizing and what happens in evolution. You need some sort of outside force, which is the source of change. And mutations, genetic mutations, are a very good example of that. But without this kind of, let's call it intelligent design, which I think is what humans are using.
Yeah, that's an interesting way to delineate what we currently can observe in humans and what we see in artificial systems. And I think this delineation can also guide further improvements in algorithms, where we might kind of admit that there are fundamental problems beyond the size of our neural networks that affect the way that or algorithms perform learning and invention, or simply creation of new outputs.
So it's a great idea. I'm not sure yet whether we're at the stage where we no longer need the human as designing the machine learning or designing the algorithm.
I'd say we're very far from there, and any estimate on time is going to be provided wrong in the future.
Sure. Yeah.
Thank you for the conversation, Simon. I hope that in our future meetings we can discuss what conclusions do you come up with in regards to this topic.
Yeah, I was going to say it's been a fun conversation for me. It's made me think about new things, which is always fun. And I hope that we can do this again sort of in person before too long over coffee.
Likewise, that would be very, very nice.
Great. Thank you again.
Thank you for coming.